continue to our work.
Yeah.
Can you see my screen?
Yes, sir.
Okay. So basically, today we discuss this one problem, and after this, we are moving to the composition of the functions. And before of this one, we are doing
Okay,
this
I'll
one.
do this.
And I will give you time, okay? But here,
Okay.
okay. So look at here. Our function is what? F of x is equal to f of x is equal to 4 minus x square, and look at here, plot the graph of that functions for the values of the x subject. So look at here we have the domain x is less than or equal to 3. As you know, this is the quadratic functions, and this is the negative sense. You know, quadratic functions have their graph is in U format, in parabolic format. So here we want to check first what is the type of the graph of that function, and after this we can measure, or we can mark the domain at the graph. Okay, so look at here,
Yeah.
when we put x is equal to 0, you know, our y is equal to what? Our y is equal to 4, and x is equal to, when we put our y is equal to what? This is equal to 3, and when we put x is equal to 2, so y is equal to 4 minus 4, this is equal to 0. And same for when we put our the negative from the negative side, so x is equal to minus 1, so our y is equal to 4 into 4 minus 1 square, this is equal to 1. So 4 minus 1, this is equal to 3. And when we put x is equal to minus 2, this gives us, so look at here, 4 minus, this is equal to 0. So if we are making the graph of that functions, look at here, we have the 0 and 4. We have 0 and 4. So this is the x is equal to 0 and 4 along the y-axis. So look at here, this is 1, this is 2, this is 3, this is 4. So our point is here. And after this, when we are putting x is equal to 1, so y is equal to 3. This is 1 and this is 3. So our next one point is like this type. So when we put x is equal to 2, this gives us 0. So this is our third one point, is where x is equal to and y is equal to 0. Same for the negative side. Look at here, x is equal to minus 1. This is the minus 1, and x is equal to 3. So this is our point corresponding to the here. And for the minus 2, this is our point is here. So if I'm draw the line, so our function is like this type. Look at here, again I'm telling you from the functions behavior from that main function. This is our quadratic function. These are already we discussed in previous sessions. uh, so this is a quadratic function, and quadratic functions have the hyperbolic graph. It will be the open, upward or downward. It's depending upon the function's behavior, and also depending upon the here, x is square of x is minus or positive. Okay, and now we are calculated from this one. So 0 to 3, we are putting the if I'm putting the third one point, this is x is equal to 3, this is equal to y is equal to 1. So from 0 to 3, we will we will move to the positive side, because our domain is in positive side. Okay, got
Yeah.
it?
Yes.
Look, look at here. This is the use the same scale. Now we find the inverse of that functions, and before of the but here he want to we want to find f inverse of the minus 5. So before of this one, we want to find the first inverse of the that functions. So how we find, I'm already telling you. So f of x is equal to y is equal to, this is 4 minus x. We can separate the values of x to the other side, and this is y minus 4 is equal to minus x square. So can I write it like this type of format? This is equal to 4 minus y. So basically in this equation, what I'm trying to do is I'm trying to multiplying with minus 1 on both sides. So this is the minus 1, x square is minus, minus is plus, and this is plus y, this is the minus, and this is the minus 4, this is converted into the plus. So I'm taking the under root on the both sides. I'm taking the under root on both sides. So x is equal to, it will gives us 4 minus y. Can you understand it?
Yes, sir, I understand.
Okay. No, eh, we are already discussed the domain and range. Our inverse function domain and range is dependent upon the main original function, and already we discussed it. Domain of the function is change into the range of the inverse function, and range of the function is direct function that is given. So this is change into the domain of the inverse functions. Okay. So
Yeah,
from this one, this is our positive side. What we say that this is our positive side. So on the behalf of this one, what I'm trying to say, we take x is equal to r, f inverse f
yeah,
inverse of x is equal to, this is equal to, sorry, before of this one, just we are replacing this one, because after our last one step is what, replace x to the y and y to the x. So this is equal to, y is equal to plus minus 4 minus x. So this is equal to, this is equal to, y is equal to plus 4 minus x. And why we take, because I'm writing the domain. So this is 0 is less than x, x is less than or equal to 3. Okay.
yeah,
So look at here. This is f inverse of minus 5. So f inverse of minus 5, it's mean we replace the value of x with minus 5. So this is equal to 4 minus into minus 5. So this is equal to 4 minus minus is what? This is plus. So this is equal to 9 of under root. This is equal to 3. Okay.
yeah.
So any confusion regarding this one part?
No, sir, no confusion.
Okay. So the rest of the parts are the same. You can replace the x is equal to 4. Here you replace the x is 3. Here you replace x is 3. Okay. And sketch the y is equal to f of x, and y is equal to f inverse of x, and y is equal to x on the same axis. Use the range is minus 6 to 6 are both axes, are the both axes. Okay. So
Yeah,
as we already described the functions graph, and now we have the inverse function. Is our inverse function is what? F inverse of x is equal to, already we will discuss it. This is equal to 4 minus x of under root. So this is 4 minus x of under root, and you can describe the functions. Graph is same for that. You can put the dummy points, and you can make the this one functions, and you know the inverse function is the same function of the original function, but it is the opposite in the sign. Or in roughly language, or in mathematical format, we are saying that inverse function is the mirror of the original functions. Okay. Is there any
yeah.
issue, or is there any issue, or is there any need to construct a graph or not?
No, sir, there's no issue, something.
Okay. So next we are moving to the find the domain and range of the functions. And CK, I was already telling you, this is the our f of x. This is our f of x, and this is our f inverse of x. So when we are, this is the domain, but on the this side, this is our range. So this is our range, but this is in opposite side. This is our domain. Look at here. This is our functions domain. So on the behalf of this one, the range of f inverse of x is what? 0 less than x, x is less than 3. Okay.
Okay.
Any confusion? Look at here. That's
No,
why
sir,
I'm
nothing.
I'm stopping here for your understanding.
Yes, sir. I understand it.
Okay. So on the
Yeah.
behalf of this one, what is the domain of that functions?
So could you repeat?
What is the domain of that function? Look at here. When we are putting our x is equal to 0, this is the maximum point is 4. And here we construct again, here we put if f is equal to 3, this is equal to 4 minus 3 of square. So f of 3 is equal to 4 minus 9. This is equal to minus 5. And look at here. Our maximum output is 5 and our minimum output is minus 5. So our domain is what? So our domain of the f inverse of x is what? This is minus 5 and 4. This is minus 5 and 4. Okay.
Yeah.
So any confusion regarding this one problem? This is the whole one problem that I'm solving it.
Yes.
Rest of the part you can do it at home. Okay.
Okay.
So is there any issue how to construct the inverse function, graphical representation of inverse function? Is there
Could
any
you tell me
confusion?
graphical representation one more time?
Okay. Sorry, what are you saying?
Can you explain graphical representation one more time?
Okay. Look at here. Here, I'm just putting the some dummy points from the domain or from the real line. If we have the domain, or we uh, bound at the domain. If our domain is given, we are bound to follow the domain. Otherwise, we are follow the real line in general. So we are putting these points, and on the behalf of this one, we construct it, and here when we put our x is equal to 0, we got y is equal to 4. This x is our input and y is our output. So in order pair format, if in order pair format, we are writing this is x and this is y, 0 and 4. So in order pair format, this is 1 and 3. In order pair format, this is 2 and this is 0. So in order pair format, this is minus 1 and 3, and this is in minus 2 and 0. And we know the I'm drawing the graph. Here we have the x and y, x and y is positive, and here we know that our x is our x is negative. Sorry, here we have the x
Yeah.
is here we have the x is negative and y is positive, but on the downside, x is equal to negative and y is equal to negative, and here we have the x is positive and y is our negative. Okay, so according
Yeah.
to these order pair, look at here. When we have 0 and 4, we take it's mean this is in the first quadrant. Why this is 0 and 4 is all positive, and when we have 1 and 3, this is in first quadrant, and 2 and 0, this is also in first quadrant. But when we are moving to the negative side, 1 minus 1 and 3, so it gives in second quadrant. And for this one, and this is so in this manner we are we have these points, and when we construct a line, or we join these points, so our graph is in parabolic format and moving to the downward side. Okay. So is there any confusion?
Yes. No, sir, no confusion. Thank you.
Okay. After this, I'm moving to the next one point, composition of the functions. Here is the compos. Mhm. Okay. Before of this one,
I'll do this, sir.
okay,
Yeah.
just a minute, wait. I'm explaining you the composition of the functions.
Yes.
So we are already discussed. This is the function. We are already knowing our input and output. Composition is basically to join the two functions or to mix the two functions in a one format. Mix
Yeah.
or joint two or more functions. This is called the composition of the functions. Okay, and here we know that we have the just g into f of x. It's mean we can construct a single one function from the two functions. So g is another functions and f is another functions. We can combine them and we can write it g into f of x of function. Same for the f into g of x. So in for f of x and g of x, and also we can construct f into g of x. Here we have the replace the values of the g with respect to f. Okay, so this is called the composition of the functions. So look at here, if I'm doing these single one part, so look at here, our if we are finding f into g of x. So f is as it is, and we know we have the g of x is what? This is x square, and now we are replacing x square in the given function. So 2 of x of square, 2 of x of square. So this is the 4 of x square. Got it?
Yeah.
So and look at here, h of x square. So when we put h of x square, so basically this composition to itself a function. This is the composition to the itself a function. So h into h of x is what? 1 over x. So this is 1 over x into 1 over, we are replacing x to the 1 over x. So what are this one? This is the x. Okay. Okay. Can you got it?
Yeah.
So look at here. You can try this one part, and also you can try this one part. Okay.
Okay. I'll do D. I'll do B, C, and D.
Yeah.
Yes, sir.
Mhm.
For B, I got the answers for x squared, and for
Mm,
C, I got the answers 1 over x squared. I'm doing D.
okay. Look at here on D and E, we have the three functions, three
Yes,
composition.
that's all.
Okay.
Yeah, I'm doing it. That's all. Yes, sir. For D, I got 2 over x squared.
Okay. Okay. Now I'm moving to the E of that part. So
Hmm.
look at here. So our function is
Okay.
our composition is H into G into F of X. So firstly we replace uh, F of X. So H. So, sorry, this is so this is replace F of h into g into f of x. So f of x is what? This is 2 of x. So what we are trying to say that we replace x with respect to 2 of x. So h into this is the 2 of x square. So basically this is the h into 4 of x square. So look at here, 4 of x is replaced into the 1 over x. So this is 1 over 4 of x square. So basically in graphical representation, what we are trying to h into g into f of x. So our f of x is entirely in the g of x. So and g of x is entirely in the h of x. So we put the f of x into g of x and g of x is put into the h of x. Okay, got it?
Yeah.
So after this, is there any confusion regarding this one problems?
No, sir. No confusion at all.
Okay. After this, using the function f of x is equal to sine of x and g of x is equal to x square, express the following functions.
I'll do it.
Here
I'll try
we,
doing it.
okay.
Which one should I do? All three.
You can do it. First one, this. Okay.
Okay. Yes, sir. For B, I got sine squared x.
Okay, B for the sine square of x. Okay, no, we are checking that one function. So f square of x. Look at here. So our f square of x. So basically, this is this of this composition of with itself function. So f into f of x. F of x is what? This is sine of x, and you know sine is as it is, and we replace add the value of the x with the sine of x. So this is sine square of x. Okay, got it?
Yeah.
So for the f and g of x, f and g of x. So f into g of x is what? G of x is equal to our x square. So we replace our x square to the sine of x. So this is sine into this is x square. This is the sine of x square. Okay.
Yeah.
So is there any confusion?
No, sir, no confusion at all.
Okay. Here I'm giving you some extra problems. You can try it this one. So h of x is equal to x cube, and f of x is equal to sine of x, and g of x is equal to cos of x. So you want to find hf into g of x. Can you try it, please?
Yes, sir, I will. I got 1 over sine x squared.
Okay, okay. So is there any confusion regarding this one problem?